Hello everyone. We've all come across this famous property in triangles that some of the three angles, of course, there are three angles in a triangle, some of the angles in any triangle is equal to 180 degrees. Now, in this video, we are going to prove this. We are going to prove that the sum of the angles is 180. This property is also famously referred to as the angle sum property in triangles. So let's go ahead. Now for this purpose, let me take a triangle. Yeah. And of course, this applies to any triangle, obtuse angle, acute angle, right angle, whatever. This talks about a triangle in general. Now, let me call this triangle as triangle ABC. ABC. So, this is triangle ABC. And let me call the angles as angle 1, angle 2 and angle 3. Now, in order to prove that the sum of the angles is 180, we are going to take the help of parallel lines. In our previous video, we have seen that for any two parallel lines, if I consider this is a set of parallel lines, and if say this is the transversal, this is the transversal which cuts the parallel lines. Of course, it extends, but I'm just showing you because you can later on imagine the scenario of this triangle here. Now, if this is a transversal, we have seen that the interior angles, that to this one, suppose this is A, then the interior angle which is alternate to the that interior angle is equal. So both the alternate interior angles are equal. Alternate interior angles are equal. So we have established this in our previous video by using the property of angles in a straight line. The angles in a straight line add up to 180 degrees. Using that property, we've established this relationship. So that alternate interior angles are equal in a parallel line. By alternate, we just mean that the angles on either sides of the transversal. Nothing new, right? So we are going to use this property to prove that the sum of the angles are equal. Now, how do we use it? So consider another parallel line parallel to BC. Consider this parallel line. Sorry, let me try to draw a straight line. Of course, even if it is not straight, you will be able to understand. Yeah, so this is a parallel line parallel to BC. So this BC, and let me call this line maybe PQ, right? And it has to touch A, right? It's touching A. And here in this figure, we are considering AB as the transversal. AB is the transversal. PQ is parallel to BC. Now, can you spot the alternate interior angles? Yeah, we can. So let me call this PQ so that you will be able to spot it on your own. This is BC, right? Of course, this is A. So AB is the transversal, PQ is parallel to BC. Look at A, the small a. These are the alternate interior angles. So I can have the one which is alternate to angle 1. Can we find the angle alternate to angle 1? Let me just change, yeah, white. So this is angle 1. And considering that, of course, we've taken AB as the transversal, so which is alternate to angle 2. That would be better for us as we have taken AB. Of course, the same proof can be proved using AC as the transversal, but now in this video, we have assumed this. AB is the transversal, so this is the alternate interior angle, right? 4 and 2 are equal. So, angle 4 is equal to angle 2. Right? Why are we doing this? We are considering this because we know that angle 4 plus angle 3 plus this angle here, 5, is 180 degrees because they are angles in a straight line PQ. Right? So this is one thing which we have established now. Angle 4 is angle 2. And the second thing is angle 4 plus, I'm sorry, it's not, it is not a circle 4, it's angle 4. Angle 4 plus angle 3 plus angle 5 is equal to 180 degrees, right? We have established, this is an established fact, of course. Maybe I can give you the reason, angles in a straight line. angles in a straight line. Now we already have 4 is equal to 2, and similarly you can also have, considering AC as the transversal, you can have angle 1 is equal to angle 5, right? So let me call this 2. Now I am going to use my two equations 1 and 2 in this equation, in this main equation 3. Let me call this equation 3. So how am I going to use, instead of 4, let me write angle 2 because they are equal. Instead of 5, let me write angle 1 once again because they are equal. So angle 2 plus angle 3 plus angle 1 is equal to 180 degrees, and we have proved, right? We have proved that the sum of angles 1, 2 and 3 add up to 180 degrees in a triangle. So we have proved this using two things, of course. One, using the properties of parallel lines, and two, using angles in a straight line. I hope you followed this through. Thank you.